Hi, and welcome to this quick recording on how to create your graph for your density lab. I have the lab document open here. At the top, it tells you how to get into the Gizmos program. Part 1 goes through how to collect data and fill in this table here and do your calculations. That's on the first recording if you need to review that. I'm going to scroll down to part 2. And in part 2, we are going to use graphs to figure out the density for aluminum and then figure out how good we did with collecting this data, or the student that collected this data. So what happened here is that a student went into the lab, had 5 pieces of aluminum, 5 different objects of aluminum. They put each on the scale to get the mass and recorded it. Put each into a graduated cylinder of water, or used water displacement to figure out the volume, just like we did in part 1. And now that we have our mass and volume data, instead of calculating on the next column our density, we're going to graph it, and we're going to use the slope of our line to find our density. And so I'm going to go ahead over into Excel and show you how to do this. I'm going to graph a set of data for alcohol, finding the density of alcohol, different than what you're doing here, so that I'm not using the same set of data. Again, when it's time for you to do this, you want to make sure you're using the data here for aluminum and not the numbers I'm about to share with you. In addition, once you have your graph created, you want to make sure it has a title. You could use this title here. That's why I wrote it in. You want to label both your y and x axes. You want to show the trend line on your graph. And you also want to display the equation and the r-squared value. And I'll show you all of that stuff. All right, so I'm going to go into Excel. I already started putting my data on. You could pick anywhere on your Excel spreadsheet and just type in your numbers. Of course, you have it already on your document, so you could copy and paste it as well if you choose. You want to make sure, however, that you're putting volume, then mass when you put it over here, because I'm going to highlight that data and ask the program to create my graph for me. And so to ensure that the y-axis and the x-axis are in the right place, you want to make sure your x-axis comes first and then your y. The reason is slope is y over x, right? Slope is the change in y over the change in x. Density is mass over volume. So we want to make sure that our y-axis is our mass and our x-axis is our volume, so that our slope is the density. So we want to make sure it's in this order. All right, so I'm going to create my graph. I'm going to highlight my numbers. I'm going to go up to Insert. My graphs, all different kinds of graphs here. The best one to use for this is a scatter plot. I'm going to click on this scatter plot one, and the one I always use is the first one. If you want to play around with the rest, you can. I would suggest not using the 3-dimensional bubbles at the bottom. But again, I always use this first one here. So I'm going to click on that. And now I have my graph. I just need to clean it up and add in all of the extra stuff that I would like. So there's 2 ways to do that. If I click on my graph, I could go up to the top left corner here where it says Add Chart Elements, and I could click that, and I could choose what I want to add to my graph. What I like to do instead is use this plus sign. I think it's a little bit easier. I like it better. Again, either way is fine. So again, I'm going to click on my graph, and this time click on the plus sign instead. I want to keep my axes. I want axes titles. So I'm going to put the units in there. The chart title I want to keep. Grid lines I want to keep. And I also want to add in the trend line. So the trend line is the best fit line through all of your data points. My data seems to be pretty good, so that line is going straight through. I'll mix it up for you a little bit and show you what happens when your data is not that great. But again, the trend line is your best fit line, closest to all of your data points. In addition to that, I'm going to click on this arrow and go down to more options. That's going to pop up this little sidebar for me. I want to scroll all the way down and click on Display Equation. That's going to give me my line equation on my chart and display the r-squared value, which I'll explain here in a moment. Okay, and then close it, you're done. So again, to review, you could click on your chart and you could go over into this top left corner to add what you want. And again, you could go to trend line, you could go to more options, and you'll get the same options to pop up in the same bar. Or you could click on this plus sign and do it there as well. Now I want to go ahead and fix all this. So I need to fix the title of my graph. So I'm going to do density of alcohol, and that's going to be mass versus volume. So it's good practice to, title your graph, and also in parentheses show what you're graphing. So we're graphing mass and volume. We want our y-axis, again, to be our volume, because we want the slope to be y over x, mass over volume. So I'm going to put mass. And again, in parentheses, did I type that right? Yeah. In parentheses, I'm going to put grams to identify the unit I'm measuring in. You should also always do that as well. Across the bottom is my volume, and that's going to be measured in milliliters. So I want to include that too. So we really have everything labeled here. The last thing I want to talk about before we finish this up is that line equation and the R-squared value. So the line equation, we know for a line is y is equal to mx plus b, right? That's a line equation you probably learned in math class. The slope of that is the m value. And so wherever that m value is in your line equation is your slope. If I look at my line equation, my m value right before the x, right, it's mx, my slope value is 0.7672. So I know that that's my slope, and you're going to use that in a calculation, or your slope that you get in a calculation. So again, your line equation is y equals mx plus b, m is your slope, and so the m value is the number that comes before your x. The other thing here is your r-squared value. And your R-squared value is an indication of how good your data is. We're not going to use it in any calculations here, but I just wanted to share with you, if you haven't seen before, what it is and what it does for you. So what that R-squared value right now is telling me is that my data is perfect. And that usually doesn't happen. But it tells you how close to the line all of your data points are. So how good your data is. And the range of number goes from 0 to 1, 1 being the best, or you can look at it as a percentage, so 0% to 100%. And so right now I'm at 100%. This is made up data. It's come directly from the website somewhere. So I'm going to switch up this data. I'm going to change one or two of these data points over here in my chart. And so let's change this one to, I don't know, 50. All right, so I changed one of my data points to 50, and you could see, let's change another one. Let's do 12. Okay. So I changed two of them, and you could see that my graph automatically adjusted. So that's good if you need to change any of those numbers. And now look at my best fit line. All of my dots are not touching my best fit line, right? So the best fit line, the trend line, is the one that the computer creates that's closest to all of those dots, right? As close it could be to all of them in the middle of them, basically. And the fact that I have so many now that are not touching the line is telling me that my data is not so great anymore. And if I look at my R-squared value, now it's at 0.5 or 50%. So I was at 100% a moment ago, and now I'm at 50. So again, that R-squared value is a good indication of how good your data is, how close to the line it is, or it doesn't have to be a straight line. It could be whatever graph that you're looking at. It's going to give you an indication of how good the data is, how good it is to your graph, how close it is to your points on your graph or the data you collected from the lab that you're doing. So again, we're just going to look at that. There's nothing you have to do with it. I just wanted to explain what that R-squared value is, and maybe in the future you could look at it to see how good your data is. So I'm going to put this back to the way it's supposed to be. Right? And now I'm done. I have my title, my axes, my line, my R-squared, and I'm just going to copy and paste this into my lab document. And so I'm going to use this Snip and Sketch program here. You could see it's called Snip and Sketch, and if you haven't used that before, you can just search it on your computer. It should pop up. I'm going to go to New, and then highlight my graph. And then I want to hit copy and then go back to my lab document and paste it in. So it says paste your graph here, and I'm just going to paste it in. And that's it. You're done. Now you have your graph. And if you scroll down a little bit, you fix it. It moved down when I pasted my graph. If you move down a little bit, now you're going to use your slope value to calculate the percent error in your data. Right? So your slope value is your experimental value, and your accepted value, your actual value, is the 2.70 I'm giving you in the problem. Right? So you're going to plug that in and solve for percent error. If you have any questions or if you need any help with anything, please let me know. Good luck with your graphs.